dendrites are like arms. They're reaching out, right? These look kind of like arms. Because the point of a dendrite is to grab the messages. So we want them all over the place so that I can connect to many neurons, Marcus. Dendrite. Then it comes to the cell body. The message comes to the cell body, and the cell body decides, is this a good enough message to pass on? If it decides that it is, shoots the message down the action potential to the next neuron. So there are 3 parts. Dendrite is grabbing the message, the cell body processes it, and the axon shoots it to the next neuron. So that's 3 points for, did I give you your points? Alright, next one. What is the function of the following classifications of the nervous system? Let's break it down into 2s. So central and peripheral nervous system. Ms. Reed, what's the difference between those 2?
The central consists of all the neurons in the brain and spinal cord. And the central contains all the neurons outside the brain.
You said central twice. What's peripheral?
Peripheral. They contain outside the brain.
Yeah, so we see this guy here. You can remember central because it's central. The brain and spinal cord, all the nerves in the brain and spinal cord are in the central nervous system. All of the nerves outside of the spinal cord are in the peripheral, like your peripheral vision. The next 2, somatic and autonomic. We're going to give it to a table who has an answer. Yes?
Autonomic controls all the things that we don't think about, and somatic controls all the things we think about.
All right, autonomic, we don't think about it because it's automatic. That's how I like to think of it. Autonomic's automatic. Somatic, we consciously think about it. Thank you very much. And the last 2, parasympathetic and sympathetic, Mr. Booker.
All right, sympathetic is when you're aware.
When you're aware.
Yeah.
Because you ain't raised your parents, so I should call you.
When you're asking, those are good examples. Are we listening to table 5 or are we talking while our classmates talk?
I'm trying to help them better understand the question.
Okay, well let's do it while our classmates not talking. Yeah. Yes, I can. So, when I was going through college, I had a really hard time distinguishing the difference between these 2.
Glossy number 8.
So I wrote them. Okay, so the only way that I can remember them is sympathetic. It's like, have you heard about people who can lift up cars in like a really stressful situation, like if someone's hurt under a car or something? That's because of the sympathetic nervous system. So when you're super stressed out, maybe someone's chasing you, you choose whether to fight them, to turn and fight them, or to flight. So we nickname the sympathetic fight or flight. The opposite is parasympathetic, resting and digesting. If you just ate something, you need to process it, you want to use your energy there, and you can kind of relax with other organs. So the only way that I was able to remember this in college, because I had no idea how to tell the difference, because they have the same word root, parasympathetic. There was this picture in my textbook, sympathetic. One of the pictures was a man standing on top of sympathetic, and he was running away. And then the other picture was a man laying on top of parasympathetic, and he was sleeping. So the way that I remembered is if I was going to rest and digest, I was going to lay down, you'd probably fit better on top of parasympathetic because there's 4 more letters on it. And if I was running away from someone, sympathetic's better because it's shorter. So parasympathetic, it's easier to lay down on top of the word because it's longer. That's the only way I could tell the difference. It's kind of a cheater way, but it helped me remember. So parasympathetic is the longer word, so you can rest and digest on top of it. Those are the differences. On the exam, you're going to have to match them. So I'll give you a description of the classification, and you're going to have to match it to the description. Now this is like the hot tamale, hard exam essay question. Yes. I know you were first, but you've already answered. Jasmine.
Jeremiah, please raise your hand.
Okay, the axon sends the message to the soma, then the soma sends message to the dendrite, then the dendrite spits out neurotransmitter to the next neuron, which causes action potential.
Okay. Very
That's
nice.
wrong.
No, that's not for you. No, that was for Marcus, who was talking during your explanation. But yes, very nice. So let's look at this here, this picture, so we can get this concept. So I'm a neuron, right? And I want to pass a message somewhere. My brain says I want to pass a message to my bicep. We have to pass the message through neurons, so like one neuron to the next neuron. But in between neurons, they don't actually touch. There's a little bit of space. So how do I get my message to Sierra if there's space in between us? There's a little chemical that spits out. So my axon sends an action potential down, but when it gets to the end, it has nowhere else to go. So its only option is to spit out chemicals, and they're called neurotransmitters. They travel in between us, and then they bind to receptors on dendrites. You know how we talked about dendrites having all these arms reaching out? They have this Velcro on them. It's kind of like Velcro, these receptors, and they fit perfectly into the neurotransmitters. So neurotransmitters jump right into the receptors, and that's how this neuron understands the message. So the words you're going to have to use in your essay are action potential, axon, dendrite, and neurotransmitter. This would be a perfect example. An action potential comes down the axon of the first neuron. When it reaches the end of the axon, neurotransmitters are released, and they travel across to the next dendrite where they bind to the receptors. Yeah, one more time. So an action potential comes down the axon of one neuron. When it gets to the end, it has nowhere else to go, right? So it spits out these neurotransmitters so that they can be like messengers and take the message from this neuron to this neuron. So they bind to the dendrite of the next neuron. Remember, dendrites have arms. They're reaching out. They want to grab messages, so they're like Velcro, trying to grab onto neurotransmitters. When they get neurotransmitters, they take the message into the cell body. It's processed, shot down the axon of the next neuron, and then neurotransmitters in between. So in between all the neurons, there's neurotransmitters. Does anyone remember the specific, so table 7 and down. Does anyone remember the specific neurotransmitter that causes addiction? Keith, where's you?
Endorphin?
Not endorphin.
I know it is, but I can't talk.
Nope. Yes, dopamine.
Terrence just helped her.
I gave it to Terrence, he said it first.
Wow, I would
But you
have
gotta
got
pick
that right.
participation.
Oh, sweet, so I don't care.
Keith, negative classical.
I said, what? I said dopamine. I had to.
I'm not taking it. Okay, reflexes.
But we still
Why does
don't
our body have reflexes? Reflexes. So, have you heard of reflexes before? Why do we want to have reflexes? Justice.
know. So we can react.
Okay, so to allow our sensory and motor neurons to connect.
Yeah, but there's like, what kind of situation? Can you give me a situation where you'd want to? So they do
Like,
connect to the spinal cord.
If I touch my hand on the what's his name, I was like,
Oh, no, what's his name? What is the person's name?
if I touch my hand like on the stove, I want to move it because it's hot, so it won't burn.
Yeah, that's right. So in a situation where you want to react fast, you have reflexes. So let's look on Terrence. Terrence, put your arm out. Okay, so we talked about how sensory goes from, so say I pinch Terrence, the message goes up his neurons to his spinal cord and then up to his brain. And his brain goes, okay, I just got pinched. Then it can send a motor efferent neuron down, or message down the spinal cord and
What
out
about the inner neuron?
to the, well, that's what we're getting to, out to the muscle. So sometimes, let's say he touches a hot stove, his body needs to react really fast. So instead of going all the way up to the brain, it goes to the spinal cord and does a U-turn so that he can move it away really fast. So then the neurons send the message out to the muscles and he moves his hand away. So sometimes when we need to react fast, we have inner neurons in our spinal cord that redirect the message right back out so that we can react fast. Like, have you ever been to the doctor and they do that thing where they tap your knee like that?
Nope, never done it.
You've never done that?
Never done it. They never gave me a sucker, did they?
Exactly. So normally when you're at the doctor, you get a knee test and they'll push on your knee right here. They're checking to see if your reflexes are working. So if your inner neurons are connecting your sensory and motor neurons. So you kick out. Yeah. So the sensory message is the hit and the motor message is when you move your leg. That's why we have reflexes.